I believe that you are able to hear me. Am I audible? Yes. Am I audible? Anyone participants, please? Yes. Okay. Okay. Thank you, Vibhuti. Thank you, Pooja. Thank you, Ashish. Okay. So, welcome back for the second session. So, in this session, we will be discussing about basics of the machine learning. Okay. Possibly these basics, it could be a case that many of you know. Okay. But just to ensure that when we will talk about in a further session about the various applications, so at that time you understand the basic terms. Okay. So possibly with this video. So means ultimately what in this lecture we are going to discuss the basic about the machine learning. Okay, some basic terminology of the machine learning we are going to discuss, because when we talk about the smart healthcare, okay, for a smart healthcare, the machine learning is a very important tool. Okay, in a healthcare domain, smartness comes from the AI ML algorithm only. Okay, so we will be discussing that. Okay, so we will talk about first data mining, then we will connect that with the machine learning, then we will talk about the types of machine learning, then we will talk about the application, and then I will introduce you about the deep learning. Okay, so first of all, what is data mining? Okay, so when we consider a data mining, then data mining is nothing but a process where we are interested to find out the pattern. Okay, now that pattern is basically carrying some sort of understanding of the data. Okay, and the data, when I consider, then there is a big data. Okay, so currently if we consider that, then there is no problem of storage. Okay, means we have lots of data which is being generated. Okay, even in a day-to-day life, we have so many data is generated itself in our phone. Okay, through WhatsApp, Facebook. So data generation and data storage is not at all a problem. Okay, but what is important that out of those data, what is relevant to me according to my application, then I need to filter it out. Okay, so that is very much important. So data mining is nothing but the process to find out some sort of pattern from a large data through some sort of mechanism which we consider as artificial intelligence, machine learning, some sort of statistic we apply and try to find out the some pattern. Now idea is we want to extract some useful information. Okay, so ultimately the information is which we want to get out of the data, and we all understand that what is the difference between them. Okay, so when we consider the information, then there is some useful data that I have obtained. Okay, so that is nothing but the information. So that information that actually helps us to transform into the more understandable structure. Okay, and in the healthcare it is very much important because we need to take some decision. Okay, like whether a particular patient has to be operated or not. Okay, if that decision I need to take it, so definitely whatever the data that you have, that data will play a very crucial role. Okay, so data mining is also known as knowledge discovery to database. Okay, so that is another term that we used to have for the data mining, that knowledge discovery to database. So that is the KDD. So ultimate objective by having a data mining technique is to discover the pattern rather than the data itself. Okay, so I am interested to have some pattern from a data, and that from that pattern I will take some decision. Okay, or maybe I will take analyze some critical condition of the patient. Okay, so that is all about the data mining. Now, data mining is basically a term which is very popular, which we can consider as a bigger umbrella. Over there, there is a AI, ML, DL, everything comes in. Okay, so over through a data mining, basically I am trying to impact some intelligence. Okay, and through which I am trying to get some sort of useful information. So data mining is a non-trivial process where we used to identify a valid data, novel, okay, which the meaning for which we are is unknown, implicit. So that means there is some information which is available inside the data, and that is not known to me. and I am trying to derive those information out of it. Previously unknown, definitely, okay, and ultimately it should have some sort of understanding with pattern, okay, and then it could be having a potential useful, okay. So that is some sort of diagnosis, some sort of detection, some sort of prevention, or taking some sort of critical decision for a particular patient. So for that, we used to have this kind of technique. Okay. Now, when we talk about the KDD, that is knowledge discovery to database, that we actually consider as a data mining. Okay. So for that, we are starting with the data and we apply some specific number of steps. Okay. And through the steps, I will try to derive the knowledge. Okay. So if we just observe that input is nothing but a database. Okay. And as I told you earlier also, so there is no lagging of the data to it. So data I can generate it. We have a very good sensor. Through that, the data is continuously generating. Okay. But whatever the data is generated, from that, I want to identify which one is relevant to me according to the application and which actually provides me the useful information. Okay. So for that, there are certain steps that we are following, like we go for a data cleaning, then we go for a data selection and transformation, then we apply some sort of algorithm. Okay, then I will identify some pattern, then I evaluate the performance of that particular pattern, and then finally I come to a one particular conclusion that this knowledge I have derived from this particular data, and this knowledge I will apply to this particular application. So data cleaning, okay, that is the first step that possibly we would like to have for a data mining process. So data cleaning is nothing but a process where we want to remove a noisy and irrelevant information. Okay, so that is very much important. Okay, so whenever we are dealing any kind of data, particularly when we talk about the healthcare data, then that is very much important that whatever the decision, whatever the knowledge that we want to derive, that should be at most accurate, because we are dealing the life of the people. Okay, so we need to understand that whatever the decision that we are taking, that should be we should have a pretty much confidence on it. Okay, so it is something like that if somebody, means I'm not feeling well, and doctor has given me some sort of advice for a surgery or operation, then definitely I will take a multiple opinion. Okay, so maybe I can go to a first doctor, whatever his opinion, I will definitely consider it. I will go to a second one, and if it was, then I will go to a third one, and then I will decide whether I need to go for this particular surgery or operation or not. Okay, so ultimately, the decision what we want to derive is very much important. When we are dealing with the healthcare, then it is at most important. So for that, the quality of the data is very much important. So quality of the data, when I consider, then there should be not any kind of noise inside my data. Of course, you need to treat the missing value, because the decision actually comes out from the data. Your decision is as good as whatever the data that you have. Okay, so quality of the data is very much important. Okay, so we need to apply some sort of pre-processing techniques, okay, or step for that. So for that, the missing value, how you can actually fill up the missing value. So sometimes we used to take an adjacent value, sometimes we used to take the average of the sum of the value, and then we will decide that what should be the appropriate value of that. But definitely, when you apply a data to an algorithm, then before that you need to handle this. Either any kind of noise is there, you need to remove them, or if there is any kind of missing value, then you need to fill up them. Okay, so that is very important. Data integration. So data integration is nothing but define that data generated from the multiple source, and that is some sort of heterogeneous structure. So it is something like that if I want to basically identify the take a decision about whether a particular patient is infected from the COVID or not. So definitely one of the decision that I can take from the SpO2 value. Okay, then possibly I will observe the symptoms, that whether there is a cough, sneezia is there, whether there is a fever is there. So I will take a data from a multiple source, that is a one SpO2 sensor. Maybe I will talk about some sort of blood report. Okay, and then I combine the data, and then I will try to take some sort of decision out of it. So data integration is also very much important, where we used to have a data from a multiple source, and from those data we are trying to take some decision. Data selection. So data selection process is very important. That means how I want to derive the knowledge out of my data. Okay. So initially you have done some sort of pre-processing, you have handled the data. Now the main part is that where actually we talk about the machine learning part. Okay. So which kind of algorithm that you need to apply to this data? So there could be a neural network, there could be some sort of classification, that there could be some sort of clustering, there could be some sort of regression technique. So all this, what is the difference among that, and where we need to apply the which kind of technique that we are going to discuss today. Okay. So data transformation. Data transformation is nothing but is defined as a process of transforming the data into appropriate form. Okay. Sometimes we are doing the mapping also. Okay. So here we need to process the data. Okay. So ultimately the numeric value is better to handle while we are doing the processing. Okay. So when we talk about the data transformation, then ultimately we want to provide data to algorithm which is more understandable and easy to process. So data mining is nothing but as we talk about that, deriving some information out of your data. Pattern evaluation, that is very much important. Okay, so we will evaluate that what is the best way to visualize our result, and whatever the outcome of our efforts through a ML algorithm, we want to visualize it. Then we want to represent it in terms of the report. We want to identify some sort of performance parameter out of it, because ultimately we need to judge that whatever the ML technique that we have applied to our data, and whatever the knowledge that is basically discovered out of it, whether that knowledge is relevant. If it is a relevant, then how close to an actual one. Okay, so for that we used to evaluate some sort of performance parameter. So that also we are going to discuss it today. Okay, so when we talk about the data mining, then for the data mining, or possibly you can consider machine learning, there are two main categories. One is a descriptive, another is a predictive. Okay, so predictive method is where you want to predict something. Okay, so whenever I want to take some sort of prediction out of my data, then I will use a predictive technique. And there are two main techniques which I can use for the predictive algorithm. One is the classification and another is the regression. We will discuss that when you need to use a classification, when you need to use a regression. We are going to discuss it in short. Another is a descriptive method. Okay, where I will identify characteristic or the property of the data. And from that, I will try to derive some decision, or maybe I will try to derive some sort of knowledge. Okay, then clustering and association. So these are the descriptive methods. Okay, now slowly we are moving toward the machine learning. So what is the machine learning? So machine learning is nothing but having some sort of programming to our computer, which actually help us to optimize the performance criteria by using some sort of data or the past experience. Now, what I am trying to say with that ultimately it is some sort of program. In that particular program, more and more data I will feed, and from that I will try to improve my performance. Okay, so whatever the performance measure that I have considered to judge the accuracy of that particular algorithm. So for that performance parameter value has to be improved by adding more and more kind of data. So that is nothing but a simple concept of the machine learning. Okay. And when I would like to have a machine learning to apply, okay, so where there is limitation of the human expertise, okay, where human expertise doesn't exist. Okay. So specifically when we talk about the healthcare domain, it is very much important. Okay, because as I said that we are trying to make some sort of critical decision out of whatever the data or whatever the report is generated out of the particular patient. So for that, if you have observed that sometimes that opinion may get changed for doctor to doctor. It is something like that, that if I go to one particular doctor, let's say Dr. A, and I will present the reports in front of him, then he will provide one kind of opinion out of it. Then I will go to a Dr. B. So again, same report, same patient information, but the decision or judgment of the doctor may change. And if I go to a C doctor, then maybe it is having some sort of judgment which is not matching with the previous two. So here, the machine learning, what is the good thing about the machine learning, that it will provide a unique outcome for every data which is being fed to. So once you have decided that this is my machine learning algorithm that I want to use it. So whatever the data that you apply, whether you apply the data today, tomorrow, or maybe day after tomorrow, it will have a same kind of outcome. Even for a human, it could be different. It is something like that. If I go to with a report with a doctor, and he has some judgment today. Maybe day after tomorrow, if I go to again with the same report to my doctor, then he may have a different interpretation. Okay, because the human tendency is that they used to actually change it, and doctor always pick up the symptoms. Okay, doctor always pick up the symptoms. What I'm meaning by that, that if I am having a cough or sneeze, and doctor will prescribe of one particular medicine. Now, if some other person comes with the same symptom, then doctor will provide with the same medicine which has been prescribed to me. But you have observed that it could work for one person, but it could not work for the other person. Okay, because there is an immunity and the body structure of each and individual is different. And doctor always provide the prescription according to the symptoms. Okay, they don't know about the whatever the body structure of it. But what happens in a machine learning, that if we train the model of a one particular patient or one particular person data, then definitely I expect that model will give you the accurate outcome for that particular patient, not for all. So there is a sort of the personalized treatment, or there is a term of the personalized medicine that could be possible with the help of the machine learning. Okay, so currently in the doctor community also, even they are also very much interested to understand the machine learning, to have one opinion. Okay, so it is something like that, that if doctor has given some opinion according to the present condition of the patient to the report, whatever is being generated. If there is a one opinion, if it comes from the machine learning, then also that will help. Okay, so if the opinion matches, then the confidence level of the doctor is definitely boosted. Okay, so if doctor suggested that there is some sort of surgery is required for this particular patient, and if your MA algorithm is also giving with the same decision, then definitely the confidence level would increase. Okay, so ultimately machine learning can help us when the human expertise is restricted, where humans are unable to explain their expertise. So at that time, the machine learning would be useful. So solution changes in time. Okay, so actually we are unable to adapt the situation which is changing frequently. Okay, but the machine can able to do. If solution is dynamical, then the machine learning can definitely help us. So you pour more and more data. So whatever the data that you have feed it inside your machine, now it will try to understand that pattern and come up with the better solution out of it. Okay, and solution needs to be adapted to a particular case. That's what I suggested. Okay, so person to person solution could be possible with the help of the machine learning in a smart health. Okay, while through a doctor, as I said, that it will just observe the symptoms and then it will prescribe the same medicine for those particular symptoms patient. Now, why do we need a machine learning? Okay, so basically some tasks cannot be defined well, except some examples. So at that time, the machine learning algorithm can help us. Okay, large amount of the data where there is having some sort of hidden relationship and correlation. Okay, when the data is large, okay, then it is very difficult to actually identify the useful information out of it. Okay, so at that time, human has a limited expertise, but definitely the machine can do a better outcome out of that. It can actually explore the hidden relationship, which is may not be explored by a doctor itself. Okay, so automatic approach will definitely help us to take a better decision. The amount of the knowledge about the certain problem and task may be too large for explicitly encoding the human. That is what we talk about. And solution changes with the time. At that time also the machine learning is very much used. Now this is just to have a better understanding of the machine learning. Okay. So ultimately what here it is important that you need to understand that in a traditional programming when we talk about. Okay. So in a traditional program what we do, we used to write down one particular program. Okay. So we used to write down a program by ourselves. Then we provide the data. So data is nothing but the input. Okay, so it is something like that. If I have written a one particular C code where I want to add 10 inputs, and I will write down a one particular C code which actually help me to do the addition of 10 number, then I will supply the input to input the 10 different values. Okay, and the computer will give me the outcome where all 10 numbers will be added. Okay, so this is now my traditional programming approach. Okay, now what does a machine learning do? Okay, so if you just observe that there is an exchange of term output and program over here. Okay, so ultimately in a machine learning, what will happen that the data is there. I will also know what is the appropriate output of that. I will supply those to a computer. Now computer will create a program accordingly. Okay, I do not have to explicitly write down the code. Okay, and possibly means at many times we used to hate the write down the coding, but machine learning is a possibly we consider it a savage for us, where we do not have to explicitly write down a code for that. What we need to do? We need to just supply the data, and we need to also supply the output. The machine will generate the code automatically, and in future, when you supply any kind of data, the output will be generated accordingly. Okay, so this is a simple machine learning concept that actually help us. Okay, now when we apply the machine learning, then what is the thing that we need to consider? Okay, so first thing is the learning task. Okay, so we need to first understand that what we want to predict or what we want to learn, and that actually derives from the application. Okay, so as I said that in some of the applications, possibly you are more interested about the predicting or maybe detecting of the disease. Okay, in some of the cases, maybe you want to provide some sort of preventive or point of care service to a particular patient. So you need to identify first that what is your application. And according to the application, you need to decide which kind of machine learning approach is more appropriate to you. Then we need to also talk about the data. We have already talked about that the data is very much important. Your algorithm is as good as whatever the data that you have applied. Okay, so for that we need to go for some sort of data pre-processing, and we need to ensure that whatever the data which is being fed to a computer, so that it can understand it in more better way, and it will generate the program which actually help us to take the correct decision. Okay, so what do we have in terms of data? What is the quality of the data? That is what important, and what we can assume about the given problem. Okay, so sometimes we take some sort of initial assumption, or maybe we will convert the values into some sort of numerical form with some sort of assumption, so that it can be processed by an ML algorithm easily. Representation. So what is the suitable representation for the example that we want to solve? Okay, so that possibly when we discuss more details in a case study, at that time you will understand the method and estimation. Okay, so what are the method which we want to apply for a particular algorithm? So there are so many machine learning methods. Okay, but which method is applicable to which kind of problem? Okay, so that also we are going to discuss in this particular workshop. And important thing is evaluation. See, everything comes with the evaluation. So it is something like that. Some students say that, sir, I have put my lots of effort and I have prepared this examination. I have prepared for this examination very well. But what ultimately speaks the result? What is the result of the particular effort? So whatever the machine learning algorithm that is being developed by us, that important thing is what is the parameter value or how you have evaluated. Okay, so evaluation parameter or performance evaluation is very much important, and through which you can judge that whatever the machine learning algorithm that you applied, whether is I consider is a good or I need to rework it and to make it better. Okay, so this is the basically a definition that I have taken it from the Wikipedia, that what do you mean by machine learning? Okay, so machine learning is nothing but a subfield of the computer science which gives the computer the ability to learn without being explicitly programmed. Okay, so here you do not have to explicitly write down the code. As I said that you write down your, you provide your data and you provide your output, and according to the data and output mapping, it will generate the program out of it. Okay, so this is a simple definition of the machine learning. Now another definition that is slightly complicated, but I will try to explain it. Okay, which gives some deeper insight of what actually machine learning does. Okay, so it is a computer program which is said to be learned from the experience E, respect to some class of task T, and the performance measure P is improved with the task T with experience. Okay, so what is the meaning of that? In simple, when I think about the machine learning, that when I apply the data, I will get some output. If I apply more and more data, then I can improve my performance. So it is something like that. That initially, when I provided the data, I get the performance value P. But when I apply more and more data to my present data set, then the performance will be improved. So that's what it's trying to say. That more and more data is supplied, the performance is trying to improve every time. And that is the simple concept of the machine learning. So now you just try to read this particular definition so that you will be able to understand it very clearly. So it is a computer program which learns from the experience. Okay, so this experience is nothing but the data. So from the data, the machine will learn. Okay, and with respect to some class of task T and the performance measure P. Okay, so with the data, whatever is being provided, machine will learn and it will try to give some sort of performance parameter value P. Now, if its performance at task T and measure by P improves with the experience E. So what I am trying to say it over here, that if you provide more and more data, then there is an improvement in the performance, and that we expect in the machine learning. Okay, so that is what machine learning is there. Now we will try to understand the basic terminology of the machine learning. Okay, so whenever from a next time onward, when we will use such kind of terminology, then you should have an understanding that what is the meaning of this particular terminology with respect to a machine learning. Okay, the first terminology is a supervisor. Okay, now what is the meaning of the supervisor? Supervised learning is a classical approach of your machine learning. Okay, where you train a machine with the data. Okay, when you provide the data, then through with the data, you will also provide the outcome. Okay, so it is something like that. That if I want to teach my 5 years year old son that this is the water. Okay, then what is my simple approach? I will show this particular bottle in front of his eyes, and initially I will tell him that this is a bottle. This is a bottle. So definitely, when I need to indicate this is a bottle, maybe 5 times, 7 times in front of my child, then he will try to realize and he will create some model inside his mind that what the bottle will looks like. Maybe the bottle is having something where there is some sort of liquid which is being filled inside it. There is some sort of top way, that there is some sort of shape is there. So once he would be able to understand the property of this particular bottle, then if I show in front of him this particular object, then he will be able to recognize that this is also bottle. Okay, so this is exactly happens in the supervised. In a supervised learning, I will provide the data, and along with the data, I will tell machine that this data is for which. Okay, so initially I didn't expect my 5-year-old son to recognize this as a bottle, but what I did it, I put this in front of his eyes and I mentioned that this is the bottle. So that's what we used to do. That this is the data, and this data is for if I am thinking about the cancer prediction. then I will consider that this is the basically report. But this report is for the cancer patient, and this report is that the patient which doesn't having the cancer. So now machine will try to visualize from that data. It will try to understand the pattern. It will try to understand the pattern that if there is a cancer patient, then what the important parameter out of this data. Okay, and if there is a data without a cancer patient, then how the pattern will look like. So it will try to identify the pattern through which it will try to differentiate that whether a particular report is for the cancer patient or it is for a without cancer patient. So here in a supervised learning, ultimately, as the name itself, we will first train the machine. Okay. When we train the machine, at that time we represent the data, and we also used to provide a label for that data, and that we consider the output. So output along with the data we will feed it, and then we expect that the model will create a one particular program. So that means that is nothing but some sort of pattern which is being generated out of that particular data, and through that pattern. Now, whenever I will provide simply a data at the testing time, it will allow me to judge the particular output. But initially, that machine has to give or feed a data along with the output. So that is we consider as a training phase. And once the training phase is over, then we expect that whatever the model is created, that will help us to get some sort of prediction out of it. So that is a supervised learning. So it is learned through example for which we know the desired output. Okay. So usually when we talk about a healthcare, so in a healthcare also, the generation of a training data is very much important. Okay, because we want to make some decision out of it. So initially, whatever the data that is being generated along with the label is very much important. So for that, what we used to do is that there is some sort of doctor panel, okay, that usually observe the data, and from that they used to provide the label. So I'm not considering the opinion of a single doctor, but maybe a 10-15 panels of the doctors is there. I will present the data in front of them, and I will ask them to make a judgment out of this particular data. So I will consider all 15 doctors' opinion, and out of which whatever the majority decision, that I will consider as a label of that particular data. Okay. So labeling of the medical data is also very much important. Okay. So that I will consider by a supervisor. So it is something like that. If I want to identify if this is a cat or dog, then that example is nothing but a supervised learning, where I present a figure or photos of the cat, and I will ask the machine to identify that how the cat will looks like, and I will present the photo in front of the machine that this is dog, and it will try to judge the characteristic of the dog, and then with the both the characteristics, it will try to differentiate that if it is a cat, then what is the characteristic that can distinguish from a dog. Okay, so are these male, are sperm or not? So that is also example of the supervised learning. And another is predicting the value of the house. Okay, so I want to predict if I want to sell my house. Okay, so for that, what could be the estimate value? So for that, maybe I will consider that what is the square meter of the house, what are the number of rooms are there, what is the locality of the house. So from that, I want to try to get some sort of prediction. So this is nothing but the example of the supervised learning. Now, when I talk about the supervised learning, where I want to predict the outcome, then there are two main methods which we used to have in the supervised learning. Okay, the first method is a classification, and another method is a regression. Okay, now classification is basically useful where my outcome is a discrete. Okay, so in the previous slide, we talked about that whether a particular, from a particular photo, I want to identify whether this particular photo is for a cat or a dog. So now here the outcome is discrete. And from this photo, I need to identify whether it is a cat or dog. Similarly, from the email which is incoming, for that I want to identify whether this is a genuine or a spam. So here outcome is discrete. That means I can count it with my finger. That what could be the probable outcome of this particular problem. If I know that what are the possible outcome for this particular problem, then that approach is a classification, where I know what are the different outcome in terms of the classes. So number of classes well defined prior. Okay, that it could be a 2, it could be 5, it could be a 10, like that. But it is countable. So whenever outcome is a discrete value, then I solve that problem with the classification. Okay, so for a cancer, if I want to identify what a cancer, the stage. So cancer stage can be first, second, third, fourth, so which is countable. So that is the problem of the classification. Now, another supervised learning method is regression. Now, regression is applicable when output is continuously changing. Okay, where there is no bounded. So in a classification, I know that there is a bounded value, that outcome can be a 5, 7, or 8, 10 class. But here, the value is continuously changing. It is something like that in the previous slide. We talk about the houses of the price. Now, houses of the price maybe today, the X amount. But if I go maybe after 3 years or 5 years, that price may change. Okay, so value may change. Now, value is also dependent upon the different variable. Like houses of the price depends upon how many rooms you have, what is the locality, what is the construction, how many old that particular house is. So all these value matters. And according to that, if any one variable changes, then value will change. Okay. So ultimately, in a regression, when I want to predict the output, then output is having a continuous value. Okay. So there is no fixed bounded. That house can be of a 20 lakh or it can be of a 20 crore as well. Okay. So there is a large range and we don't know that what is the exact outcome. Okay. So that when the value is continuously changing, we used to have a regression machine learning model, and regression and classification both comes into a supervisor. So just to indicate that when we talk about the classification in the data, then we want to draw a particular line where I can differentiate between these two data. And basically regression is nothing but a curve fitting. In a basically regression, I want to put a one particular line such a way that all the data point would be on the particular line. So we will be discussing on this particular topic in more detail, possibly in next 5-10 minutes. Okay. But initially we want to understand that what is the difference. So supervised learning is having a two techniques. One is the classification when output is discrete, and another is the regression when output is continuous. Now classification. So classification is a method of separating the data set into various categories or classes. Okay, by having a label. Label is nothing but my output. So it nothing but assigns the data point to a specific group based on the particular criteria. That criteria is also we used to define as a feature. Now, according to the feature, I will define. So it is something like that. That if there is a one particular picture, and from that picture, I want to judge whether this particular picture is for a man or a woman. Okay. So definitely, if you want to differentiate from a particular image, whether this particular image for a man or for a particular woman. So for that, you will try to identify the features out of this particular picture. So maybe you will think about the hair. That hair could be one of the features through which I can identify that whether a particular male, this particular photo is for a man or a woman. Okay, if there is a long hair, then it is most likely to be a woman, but not necessary. Okay, because there are some men are there who are also having a long hair. So now in this particular case, it could be a case that with this particular feature of a long hair, I can able to differentiate the man and woman in 80% of the cases. But remaining 20%, for that I need to think about some another feature. So maybe I will think about the clothes. Okay, so if there is a salwar kameez, then it is most likely to be a woman. If there is a jeans and t-shirt, and it is most likely to be a man. But now, again, there are some women are also there which used to wear the t-shirt and jeans. So now, again, with this particular feature, it will be very difficult. But if I combine long hair and your t-shirt and jeans, possibly 2 weeks, I can more appropriately classify that whether a particular picture is for the man or woman. Maybe if still I want to improve the efficiency or accuracy, then I will think about a third picture. Maybe I will think about a mustache. Okay, and if there is a mustache, then definitely there is a male. So if all three features is combined, mustache is there, jeans t-shirt is there, and short hair, then possibly there is a most likely that we will come up with a solution accurate, which is a male. Okay, but not always necessary. Okay, so I will try to add features one by one and to make my output more and more accurate. Okay, so different classification methods are being used in the medical field, such as estimation of the efficiency of the surgical operation, medical tests, medication, investigation. So which actually help us to get some sort of relationship between the clinical and diagnosis data. So there are various kind of decision classification algorithm is there. Decision tree is there. Your KNN algorithm is there. Support vector machine is there. Neural network is there. Naive Bayes is there. Okay. So ultimately, when I decided classification, then classification is always useful when I want to predict a discrete outcome. So classification is nothing but the process of finding a model that describes and distinguishes the data classes or a concept for the purpose of being able to use the model to predict in terms of the class. Okay, so ultimately here it is a supervised learning technique. So where we need to first train with the model to a machine, and once the machine is being trained through a training process, then we expect that it will be able to generate some sort of outcome. So ultimately, what I want to do, I want to draw one particular line. This line is nothing but a model, which I consider as a classification model. And through this line, what I want to differentiate, I want to differentiate these two data. Okay, so here, if you just observe that there is a one kind of data which is having a circle and red color, and there is another kind of data which is having a green and the plus sign. Okay, now I want to draw a line such a way that it will able to differentiate the red circle with the plus green sign. Okay, and that model should be efficient, which should be able to differentiate this particular class. So this is a just classification example that possibly means these are the data that you have, but this is just for the income tax refund where you have a whether you are claiming a refund status, your marital status, and your taxable income, and whether whatever the data which is being fed by a user, whether that is the data which is genuine or not. So ultimately, from the IT department, once they want to verify your return, whatever will be filed, so they need to identify that whether a particular person has filled up the genuine detail. So whether he has claimed the refund or not, if there is a refund is being claimed, whether it is genuine refund claim or not. So that is basically a cheating case. Okay. So if genuine refund is being claimed, then I consider there is no cheating. But if there is some way the refund is being claimed which is not actually has to be, then that is being considered as a cheat case. So there are some data which is there. Okay. Where I will consider refund, marital status, and the taxable income as one of the feature. And from that feature, I want to identify whether a person is being cheated or not. Okay. So that now there are various kind of classification algorithms are there. That linear discrimination analysis, quadratic discrimination analysis, KNN algorithm, support vector machine, decision tree, random forest. Okay. So all these algorithms are there. Okay. Usually when you go with the programming, so at that time, whether you go for with the Python or a MATLAB script, so all these models are available. You need to just simply call them. You do not have to actually build up this particular model. This model is already being there inside your library. Okay, so you need to just call them. Okay, so for this particular model, maybe I will go for a QDA. For this particular model, I will go for a KNN. Maybe for a SVM. Maybe decision tree, random forest. Okay. Most of the time, what we used to do, we used to apply all the algorithm to our data and identify the performance parameter and a particular algorithm which gives the best performance measurement, which we consider as the best fitted algorithm for this particular problem. Okay, but ultimately you need to also understand your algorithm, that algorithm characteristic, and how actually it can be mapped to a particular application. So for one particular application, maybe the decision tree or random forest is giving a better result. For another application, maybe the SVM will give you the better result. Okay, so you need to understand the algorithm. So that's what I am trying to explain it maybe in a very brief manner. Definitely in more detail when we talk about the application, at that time we will be discussing. But one is the KNN algorithm. Okay, so KNN algorithm is basically based on the distance. Okay, I am trying to find out the distance and whatever the minimum distance through which I am trying to identify the class. Okay, so I will try to observe the one particular data point, and I will try to identify that data point is near to which particular class, and according to that I will take a decision. Okay, so that is the KNN algorithm. Okay, so where I will first determine the K, that is the number of class. Okay, then measure the distance between the your test sample, that is the one unknown data point with the that class. So I will find out the distance, then I will find out the minimum distance out of it. So maybe one data point is there, and there are three classes there, A, B, and C. So that data point distance I will find out from the class A, class B, and class C. And out of all three class distance, whatever the minimum distance that I have, that I will assign to that particular data. So if that data point is nearer to the class C, then I will consider that the data point has to be placed inside the class C. So that is the approach that I apply in a KN classifier. Then there is the decision tree. Now decision tree is basically graphical representation of all the alternatives for your decision. Okay. So usually we will used to take from a particular feature yes, no kind of decision. If this is the yes, then I need to follow this particular path. If there is a no, then I need to follow this particular. And again, for that particular decision, I will again bifurcate yes and no, and through which I will try. So here it is some sort of decision kind of structure. Okay. So from a particular root level, from a starting with the one particular feature, I will try to go for a different leaf node. Okay. And from that leaf node, I will try to reach out to a one particular decision. So that is a nothing but a decision tree. Okay. Random forest. So you can consider a random forest is you can consider one level up of your decision. Here, when we talk about the random forest, then you have multiple decision. Okay. So in a previous slide, we are talking about the one decision. But when we talk about the random forest, then in a random forest, you have multiple decision. And out of that, each individual decision tree, you are trying to get some particular outcome, or you are getting one particular outcome. Okay. And I will consider a majority voting among all the decisions. Okay. So it is something like that for this data set, I will apply to a decision tree 1, and there is the decision tree 2, and there is the decision tree 3. So here for the decision tree 1, the outcome is class A. For the decision tree 2, the outcome is class B, and for the decision tree, outcome is class B. So I will consider that out of these three decision tree, the class B is having a majority. So I will consider that according to the majority that this particular data set outcome is class B only. Okay. So random forest is you can consider a more rigorous way to identify your output. Okay. Naive basis. So naive basis is basically a statistical technique, okay, where we use to have some sort of probability. We want to identify the probability outcome. Okay. So through a probability based theorem, we are trying to judge a particular outcome, and then we will take some decision. So this probability theorem. So this is I'm finding the probability of X with respect to Y. So this basis algorithm that we have already seen in possibly our 11 and 12, and through which we are trying to judge our outcome. Neural network. Okay, so that is also one of the very popular one. Okay, where we are trying to create a one network which actually mimic the performance of our brain neuron. Okay, so when we try to talk about the neural network, then in a neural network we are talking about a three layer. First is the input layer, then there is the hidden layer. Now there could be a multiple hidden layer, or that could be a single hidden layer. If there is a multiple hidden layer, then we used to term that is a deep neural network. Okay, so there is a multiple hidden layer, and in a particular hidden layer also we can have multiple nodes. Okay, and through that multiple nodes, I will lead to a one particular output, which is I derive from the output layer. Okay, so possibly in a one particular lecture, the neural network will be explained in more detailed way Okay, and then we will be discussing about the CNA. So Dr. Kuldeep, possibly he will be discussing more about the neural network and the different variant of the neural network. But neural network could be useful for the classification or it could be useful for the regression network. Then there is the support vector machine. Okay, so support vector machine is also one of the very popular classification model. Okay, where we used to have a one particular model like a one particular line. Okay, so this is the middle line I am considering. Sorry, this middle line. Okay, and through this middle line there is a some margins are. So if you just observe that there are some margins in that. So that possibly considered as a good classification. So it is something like that between two countries there is a one border line. Okay, but along with the borderline, there are some margins that we are considering. Maybe a 2 kilometer area from the borderline, upside and downside. Okay, so there is a no movement of the people. Okay, so here also when we do a classification, then there is a some particular model, and through this model there is a some sort of margin that we consider. There is a delta margin, and there is a delta margin over here, and we want to ensure that there is no point which lies inside this particular area. Okay, and that we consider as a one of the very good classification. Okay, because ultimately through a classification model, I want to classify for my data that what is particular data, whether the outcome is A or whether the outcome is B. So I want that whatever the line I will draw it, that line should be accurate enough where there is some sort of margin is there, and all the data points should be at the farthest distance from this particular data points. Okay, so if you just observe, there are so many data points with the blue and the red color, but there will be definitely you can have an infinite solution. Okay, to separate these particular two data points, but out of those infinite solutions, there will be one solution where the line from that particular line, all the data points having the largest distance, and that particular line is considered to a best fitted model for this particular problem. Okay, so this you can get it with the support vector machine, where you can have a different kernel as well. Okay, where you can change the shape of this particular model. Okay, here I have shown a straight line, but it could be a maybe some sort of helix structure, maybe it could be some sort of round structure. So there are different kernels are there. Okay, so that also we are going to discuss. So there are the application of the basically the classification model. Now, in order to judge the performance of the classification model, the important parameter is the confusion matrix. Okay, so whenever we want to solve a problem of the classification, at that time, the performance is being mainly judged with the confusion matrix. Okay, so confusion matrix is very important performance parameter when I want to solve a problem of a classification. Okay, so if we just observe that confusion matrix, there is some sort of matrix. Okay, this is in between whatever these four blocks is there. That is a confusion matrix. Over there, each block is being defined some sort of notation. Okay, now if you just observe for this particular matrix, there is a left hand side I have written something that is a predicted value, and on the top I have written something that is the actual value. Okay, so actual value is nothing but a label that is being generated from a doctor's opinion. So it is something like that. I have means just shown this particular X-ray from a means from a particular patient, and I will ask the doctor that what is your judgment whether this particular patient is having a COVID or not. But I have not considered a judgment of a single doctor. As I said that I will take a judgment of the 10 or 15 doctors, and then I will decide that this particular X-ray image is for the COVID patient or not. So that label is being generated, and that label I am considering as the actual value. Okay, so we talk about that this classification is basically comes under the supervisor, and in the supervised learning, always the training of the model is very important. While training, you need to provide the data and along with the label or output. So output and data both you need to provide to a model so that model can learn out of it. Okay. So whatever the output is that I know for that particular data is the actual output. Okay. And from the model, whatever the decision which is being generated and whatever the output which is being generated, that I consider as the predict. Okay. So when I create a model and I supply the data, it will generate some particular output. Now, whatever the output is being generated, whether it is correct or not, so that I can judge it through a performance parameter of the confusion. Okay. So here in the confusion matrix, if you just observe that there are 4 boxes are there. Out of 4 boxes, 2 are the green, which we consider as a desirable value, and 2 are a red, which we consider as the undesirable. Okay. So ideally, for my data point, I want that data point should reside in a green color box. Now there are 2 green color box. We have one is a TP. A TP stands for true positive, and there is another box which is TN. TN stands for true negative. So there is a true positive, there is a true negative. Now what is the meaning of that? True positive is there when your predicted value is positive and your actual value is also positive. So it is something like that. From this particular X-ray, my model will identify this is a COVID patient. And when I ask the doctor and taken the opinion, he also suggests that this is the X-ray image of the COVID patient. So now model output is matching with the doctor opinion, and then the doctor opinion I am considering as the actual value. So predicted value comes from the ML model, and actual value comes from this I consider as a golden value or the reference value. Okay, through which I compare. So my expected is that whatever my predicted value, which suggests as a positive outcome, should match with the actual positive outcome, and that I consider as a true positive. So true positive is nothing but the cases where your actual positive is matching with the predicted positive, and that I consider as a true positive. Similarly, important is this box. Another box is a true negative. Now, what does the meaning of the true negative? The true negative says tells that if my model predicted that this value is negative, and actually also it has been identified it is a negative. So it is something like that, that for this particular X-ray, my model has generated that this is not the COVID positive patient, it is a COVID negative patient. That means this particular X-ray patient doesn't have a COVID. So that's what my model has predicted. And actually, when I show this particular X-ray image to a doctor, and doctor will also provide the same thing that this is not the patient of the COVID. So when that matches, then that is the true negative. So that means model has predicted the negative outcome, and actually to a reference model also, which comes from the doctor, he also suggested it is a negative. So true positive and true negative is an actual desirable outcome. So that means from the X-ray images, I should able to predict exactly that this image is for the COVID patient. If it is a COVID patient and it is matching with the doctor opinion, then I consider it as a true positive. And if this is not for the COVID patient, this is for the healthy patient, and the doctor is also giving the opinion that it is a non-COVID patient image, then it is a true negative. So my model should able to judge clearly whether this particular image is for the COVID patient and this particular image is for a not COVID patient. So that I consider as a true positive and true negative. Okay. But when you create a model through a machine learning process, then there bound to be an error. Okay. So there bound to be an error. Okay. And the error is nothing but these two red zones. So there is a type 1 error which we consider as a FP, that is false positive. False positive I am considering as a type 1 error. So what is the meaning of this? That my model has predicted this as a positive. Model is saying it is a positive. Okay. But actually it is negative. Okay. So model is predicting it as a positive, but actually it is negative. So there is a mismatch. Model says positive and means actually it is a negative. So there is a mismatch case. So that is nothing but a false positive, which is the type 1 error. Okay. Another is a type 2 error, which we consider as a false negative. Now over here there is a reverse case. Here the model has predicted negative, but actually it is positive. In a type 2 error, the model has given a verdict that it is a negative. So it is something like that from these X-ray images. The model has predicted that this patient doesn't have a COVID. But actually, when I asked the doctor, then doctor has suggested it is a COVID case. So that is the type 2 error. So that we consider as a false negative. Where actually it is a negative. Sorry, actually it is a positive, but model has predicted is a negative. So that is your type 2. Now I want to ask to all the participants that out of these two, which one is more dangerous in a healthcare? Okay, so the error can happen either the type 1 or type 2. But what do you consider is a more dangerous? Okay, type 1 or type 2? Which you consider as a you should be avoided? Yes, type in a chat box. Type 2 error or type 1 error? Type in a chat box. Type 1 or type 2? Open the chat box. I want to see that what people are saying. Type 2. Type 2. Okay. So Anu, Farhan, Pooja, which I consider they are the active member. They are typing is the type 2. Okay. What about the remaining? So they are remaining in a don't care condition. Okay. So for that also I am not caring. So Chintan has also defined type 2. Okay. So those who have typed their answer, they are the correct one. That type 2 error. Okay. Because if a person is being infected, it is something like that. That if a person is having a cancer, okay, and my model has suggested that it is not having a cancer. So that means the treatment gets delayed. And it could be a case that if there is a cancer stage 1, then it may enter into the cancer stage 2 or 3. Okay, so type 2 error is a more dangerous in a healthcare because if it is not being detected, then you will not start the treatment. In a type 1 error, what will happen that there could be a case that model has created positive, but actually it is negative. So that means treatment has been started. Maybe after a few times when you again come up with the report, at that time you will realize that now there is no more this disease exists. Then it's okay. Okay. But in a type 2 error, what will happen that the disease is being remain undetected. If something remains undetected, then the treatment will not be started. Okay. So that's why a type 2 error in a healthcare is a more prominent. You actually want this FN FP to be 0. So it is something like that. If I have 100 data points, I want that 100 data point should be either placed in a TP or TN. Okay, but not always it is necessary. It could be a case that 90 will be in TP and TN and 10 will be distributed. But definitely in a healthcare point of view, I want that in FM it should be as minimum as possible. Okay, then I will consider that that is a good particular model which is I have generated. Okay, and there are some sort of performance measurement that you will derive out of your this particular means confusion matrix. Okay, so as I said that confusion matrix having a 4 parameter: true positive, true negative, those two are desirable, false positive type 1 error, and false negative type 2 error is an undesirable. Now the accuracy, what I will consider as accuracy. So total instance which is correctly classified, what are the correctly classified? True positive, true negative. Those box which are green, those are correctly classified. And total number of instances. Okay, so instance may be classified as a type 1 error or type 2 error. That is a FP or FN. That is the total number. So if it is something like that, 90 are being placed in TP and TA, and 10 are either in a FP or FN or with the combine of FP and I have a 10. Then model accuracy is 90%. Okay, so that is the meaning of the accuracy. So confusion matrix is nothing but a true positive, where you have actual positive and classified is also as a positive. True negative is classified as a negative and actually also it is a negative. While false positive is actually negative, classified as a positive, and your false Sorry, false positive is classified as a positive and actually it is a negative, and the false negative is nothing but actually is a positive and classified is a negative. Okay. Apart from that, there are some other important parameters also which we need to measure. Accuracy is not the only parameter through which we can judge the performance, specifically in a healthcare domain. Okay, why? We are also going to discuss in a maybe in a couple of slides. Okay, but apart from accuracy, we also used to judge some other parameter. Okay, and another parameter is a precision. Okay, now what is the precision? Precision is nothing but the true positive divided by true positive plus false positive. Okay, and recall is nothing but true positive divided by true positive divided plus false negative. Okay. Now, why we need a confusion matrix and why we need a different performance parameter? Okay, so just to give you a motivation and clear-cut picture that why we need to also identify the precision, recall. There is a F1 score is also there. So why we need a different parameter apart from accuracy? Okay, so we cannot rely on a single value of the accuracy when we are talking about the classification problem in a healthcare and where the data is imbalanced. Okay, now what I meaning of the imbalanced data? Ideally, if I consider that I want to maybe identify the problem of the cancer. Okay, then if there is 100% of the data, then there has to be 50% data of the non-cancerous and the 50 data of the cancerous case. So ideally, I want that whatever the classes, whatever the outcome that I want to predict, that has to be equally contributed inside my data so that I can train in a better way. Okay, because at the time of the training, I want that the training, because it could be a case that I have fed a one class data, and model will able to judge that the member of that particular class very well, but remaining class data is not fed very well. So machine is unable to understand the exact pattern for those classes. Okay, so we cannot rely on a single value of the accuracy in the classification model when the classes are imbalanced. Okay, so for example, if we have a patient data set of the 100, out of which 5 is having a diabetes and 95 are a healthy. So it is something like that. I have a database of 100 patients, and out of them 5 patients is having a diabetes and 95 patients is a healthy, that is a non-diabetic. Now, however, if our model is only able to predict the majority of the class, that is 100 people are healthy, even though we have a classification accuracy of the 95%. What I try to say over here, that if your model you have prepared, that model is only able to judge a healthy patient. Whatever the data you provide, it will give the outcome as a healthy. It is not able to understand the diabetic patient characteristics. Okay, not at all. What is the case over here? Out of 195 is a health, and our model is by default judging all the patients as a health. So in that particular case also, our accuracy is 95%. Why? Because there are 95 patients are of a non-diabetic, and our model is predicting all the patients as a non-diabetic. So that means our accuracy is 95%. But can I consider this as a good model? No, because it is not able to differentiate a diabetic patient and a non-diabetic. Okay, why? The problem is over here because we have a data of a very huge 95% data of non-diabetic, and model is being trained very well with the non-diabetic patient data. So my model, whatever is being generated out of this data, will judge those who are having a non-diabetic condition, but it will not be able to judge or classify the patient which is having a diabetes because of the imbalance of the data. Okay, so that's why ideally I want that 50% of a diabetic and 50 of the non-diabetic inside my database, and then I need to apply the machine learning. Okay, so that's why we need, when we are taking care of the healthcare related data. So at that time also, we need to initially screen our data. And through screening, we need to identify that whether whatever the classes which I want to categorize, for that all the classes, the data should be equally distributed or marginally. It could be 60-40, it's okay. Ideally, I want 50-50. Okay, 60-40 is okay. But 80-20 is highly imbalanced. Okay, it will not help me to create a good model out of it. Okay, so that's why we need to go for a data balancing. Okay, so we will be also discussing about that, how you can balance the data for that. Okay. Now, just to give you the example how the confusion matrix will be helpful to calculate the different parameters. So it is something like we have a total 10 data set which comprises of cat and dog. Okay, and we have prepared a ML model which actually help us to identify whether a particular picture is of cat or dog. Okay, so initially I have trained the model with showing this picture is of cat, this picture is of cat, this picture is of cat. So I have possibly trained the model with some 100 of the images of the cat and some 100 of the images from the dog. Now model is being created by a machine. Now I want to generate the prediction outcome, and this predicted value is being defined over here. So here there is the actual value in a sequence, that first is a dog, second is a cat, third is a dog, fourth is a cat, fifth is a dog, sixth is a dog, seventh is a cat, 8 is a dog, 9 is a cat, and 10 is a dog. So this is being identified. So 10 different images is being considered, and according to those images, the label is being assigned into a actual value, starting from a dog to ending up to a dog. So dog, cat, like that. Okay, and the model has also predicted its outcome. So first image is identified as a dog, second is also a dog, third is a dog, fourth is a cat, fifth is a dog, sixth is a dog, then 7, 8, 9, 10 all are. Okay, so this is my predicted outcome. Now I need to prepare a confusion matrix. Okay, so confusion matrix is having a 4 values. Okay, one is a TP. What is TP? TP is nothing but model has predicted the value positive. Okay, and my actual value is also positive. When actual positive and predictive positive met, then we consider as a TP. Similarly, on contrary of that, the model has predicted the negative, and actually the value is also negative. Okay, so here we are interested to judge the outcome as a cat or not. So not cat is nothing but a dog. Okay, the picture is of either cat or dog. So from a picture, if I judge that it is a cat, then I consider it is a true positive. If from a picture I consider this is not cat, so if it is not cat and but obvious, it is a dog. Okay, so that I am considering as a true negative. So if a cat is correctly classified by a model and it is actually a cat, then it is a true positive. While if this is not a cat, not cat case means a dog, and model has also predicted as a dog, then I consider as a true negative. While there is the other way around, error. So in error, if my model has predicted it is a negative, but actually the value is positive. Actually value is positive and this is negative. So this is false negative. This false negative is nothing but my type 2 error. Okay, so this is nothing but my type 2 error. Okay, and this one, where my model has predicted the positive. Okay, why actually the value is negative? Okay, so this is nothing but type 1. Now I want to identify that what is the performance measurement of my confusion matrix. I want to put all these values. Okay, so just try to observe it. देखो, actual dog. So dog is nothing but not case, not cat case. Not cat case is a true negative. Okay, So actually this is the dog and predicted is a dog. This is the one. This is also dog. This is also predicted a dog. This is also third case. There is a dog and predicted is the dog. So there are total 4 values. This is also dog, predict actual and predict. There are 4 values. 1, 2, 3. Where actually it is a dog and predicted is also a dog. So dog is nothing but a not cat case. Here I am preparing a confusion matrix to classify whether it is a cat or not. And not cat is nothing but a dog. So this dog is not cat case and that I consider the true negative value, and true negative value is 4 over 8. Now similarly, my actual problem is I want to identify as a cat. So what are the true positive? Actually also it is a cat and my model has also predicted a cat. If you just observe it, this particular case there is a cat, here also it is a cat. This particular case it is a cat, here also it is a cat. This particular case it is a cat, here also it is a cat. So there are 3 instances. Okay, where actually value is a cat and predicted value is also cat. Okay, now apart from that, if you just observe that, there are few instances where model has predicted as a dog, but actually it is a cat. So I need to find out where actually it is a cat, but model has predicted as a dog. If you just observe it, actually it is a cat, model has predicted a dog. So this is the only one value. That's why I am putting the one which is my false negative. And apart from this, if you just observe, there are 2 instances where actually it is not cat is nothing but a dog, and model has predicted a cat. This 2 case is nothing but my false positive. So this all about the interpretation of your confusion matrix. Now this is very important parameter. So usually when you do write down the code, then automatically this will be taken. Okay, but you need to understand, okay, manually as well, that how you can calculate the true positive, true negative value, false positive, false negative value. So that is I have explained it over here. Okay, now that's true positive, true negative, false positive, false negative we have discussed. Okay, accuracy also we have discussed. What is accuracy? That is your corrected classified value. What are the corrected classified value? TP, that is true positive and true negative and overall value. So overall value is nothing but true positive, true negative, false positive, false. Okay. Now recall is defined as the ratio of the total number of correctly classified positive divided by the total number of positive. Okay. So here I am more interested towards the identifying the positive cases. So that is the true positive divided by true positive divided by false negative. Okay. Then there is the precision. So precision is nothing but a true positive divided by true positive plus false positive. So precision is nothing but defined as the ratio of total number of correctly classified positive divided by total number of predicted positive. So predicted positive में false positive भी आ जाए, ठीक है? So correctly classified positive true positive है और predicted सारे positive कौन से हैं? True positive plus false positive. Okay. Then there is a F1 score. So F1 score is nothing but the combination of precision and recall. So I want to identify that those who are correctly classified and those who are not correctly classified. So for that, recall and precision both I am considering, and that I consider as a F1. Okay. So for this particular example, what we discussed, if I consider accuracy, then accuracy is nothing but true positive. ये मेरे 2 box जो मेरे ग्रीन कलर के थे कंफ्यूजन मैट्रिक्स वो मेरे इंपॉर्टेंट है. तो यहाँ पे ट्रू पॉजिटिव ट्रू नेगेटिव की टोटल 7 वैल्यू है और बाकी की टोटल वैल्यू क्या है 10. तो 7 out of 10. So this defines that my accuracy is 0.70 or I consider it is a 70%. ठीक है. फिर recall. What is recall? True positive divided by true positive plus false negative. तो ट्रू पॉजिटिव कितने 3 है और ट्रू पॉजिटिव और फॉल्स नेगेटिव दैट इज 3 plus 1. So 3 divided by 4 that is my recall value and that is nothing but 0.75. So that is a 75%. Precision. Precision is nothing but a true positive divided by true positive plus false positive. So this is nothing but a 3 divided by 5. So this is nothing but the 0.6. Okay. From that, you can find out the F1 score, precision and recall, and then the specificity also. So specificity is nothing but true negative divided by true negative plus false positive. So specificity will be identified at how confident about your negative value. Okay, so that is also very much important. Okay, so just to try to understand an interpretation of each and every parameter. So what is precision? Precision is actually giving you the information how certain you are about your true positive. Definitely you want to line up. If you want to identify a disease, whether a particular person is suffering from that particular disease or not, like diabetes. So for that, this value is very important. That model is also detecting as a diabetes and actually is also diabetes. So that is the true positive. So that is my true precision. Okay. And recall. Recall is nothing but how certain you are about you are not missing any positive. Okay. कि जो पर्सन का डायबिटीज है उसको मैं डिटेक्ट नहीं कर पा रहा, that is nothing but a recall. So ideally I want that my model should classify all the positives correctly. But through a recall, I am trying to judge that how my model is actually missing to identify the positive. Okay. So recall is the nothing but the process of occurrence where the false negative is unacceptable and intolerable. Okay. So for example, in case of diabetes, you would rather have some extra false positive over some false negative. आपको डायबिटीज डिटेक्ट करना बहुत इंपॉर्टेंट है, ठीक है. Precision. Precision is nothing but you want to be more confident about your true positive. Okay. So for example, in case of the spam mail, you would rather have some spam email in your inbox rather than some regular email in a spam box. तो spam box के email होंगे वो तो मैं कभी चेक ही नहीं करूंगा. ओके. अगर नहीं होगा तो मैं तो ट्रीटमेंट स्टार्ट ही नहीं करूंगा. तो मेरे लिए तो इंपॉर्टेंट ये है कि मॉडल मुझे डायबिटीज प्रिडिक्ट करके देना है. अगर डायबिटीज प्रिडिक्ट ही नहीं हुआ देन देयर इज नो स्टार्टिंग ऑफ द ट्रीटमेंट फॉर. ओके. दैट इज द एग्जैक्टली द सेम थिंग. ठीक है. तो मुझे डायबिटिक रॉन्गली प्रिडिक्ट होगा वो चलेगा, लेकिन डायबिटिक है और नहीं प्रिडिक्ट होगा वो नहीं चलेगा. सो दैट मींस टाइप 1 एरर आई कैन अफोर्ड, बट टाइप 2 एरर इज मोर क्रिटिकल दैट आई कांट अफोर्ड. I can't afford to miss the case where there is a diabetic but it is not being detected by a model. Okay. Specificity. Specificity is you want to cover all your true negative. That means meaning is we do not want any false alarm or false positive. Okay. So it is something like that. If I am going for a drug test on a people, then those who actually tested positive with my drug, I will just consider a decision that those who are consuming the drug and for that it is being tested positive, they should go immediately to a jail. So that is my word. But I need to ensure that no false person or no innocent person should go to a jail. Okay. So that is also important for me, that any innocent cannot be tested as a positive so that he has to go to a. So that is nothing but the specificity I am talking about. Okay. So important interpretation of this particular example of the cat dog, that accuracy of the 7% means that identification of 3 out of every 10 is incorrect. I have 7 correctly classified as a cat or not cat. Precision. Precision 60% means that every 4 out of 10 cat is not a cat. And 6 still are a cat. But 4 are not my cat cases. Recall is 70%, which means that 3 out of 10 cats in reality are missed out by our model. Those are the cat but not being detected over here. And specificity value 60 means 4 out of every 10 dogs in reality are mislabeled as a cat, but 6 are correctly labeled as a, जो cat नहीं है उसको भी मुझे correctly label करना है, जो dog है उसको मैं cat नहीं बोल सकता, ठीक है, जो कोविड वाला है उसको मैं नॉन कोविड नहीं बोल सकता, ठीक है. Another important parameter for the classification is cross-fold validation. Cross-fold validation is also one of the very important indicator to measure the performance of the classifier. Okay, so we talk about the classification. Classification comes under the supervised learning, if you remember. Okay, I told you at that time it comes under the supervised learning. And when I say a supervised learning, then we need to train the model first. Once we train the model, then program is being generated inside the computer. Then you expect that you generate the outcome out of it. But initially you need to train the model. Okay. While you are training the model, you need to supply the training data. Okay. So usually what we used to do that, if I have 1,000 samples, so from the 1,000 samples, I will train the model with some sample. So usually we consider 80-20 or 70-30 base. So that means 700 or 800 data I will use for the training purpose, through which I will train the model. And remaining 200 or 300 I will use for the testing or the validation, for which I want to judge my outcome. Okay. So always from your data set, the training is very important. And you have to apply maximum data for a training. See, you ask the machine to understand the pattern. Okay, our human tendency is very clearly that our mind is very well trained that we can identify the differences in the things very well. But when you ask machine to do that, then machine will take some time. But when it identifies it most correctly and it can perform that task throughout the day, 24/7. But for the human, it may change over a time. Okay, if I am a good friend of mine, maybe I will take a very good decision. But when I am not in a good friend of mine, maybe I will take a wrong decision. But for a machine, I consider that machine will be always in a good frame of mind. So always it will take a unique correct decision. And that depends upon how good my data is being provided or being fed to a machine. So while we are feeding the data, at that time we are bifurcating. Okay, that we are using 80% of the training data and 20% of the testing data. Okay, now let's consider that I have 100 set of data, which I am labeling from 1 to 100. Okay, and I have bifurcated that 21 to 100 I will use for a training and 1 to 20 I will use for a testing, for which I will measure the performance. So 21 to 80, whatever the data that I have used to train the model is very much important, because through this data only model will train and understand the pattern. Okay, but what will happen that if I change my training set? So here what I have done is I have taken a 20% of the testing data. So in the next time, what I will do, that this 21 to 40 I will use for the testing purpose, 1 to 20 and 41 to 100 I will use for a training data. If you look at this particular case, then this case is also having a 80% of the training. But how it is being bifurcated? 1 to 20 and then 41 to 100 is being used for the training. And what testing? Testing is for 21 to 40. Now if you do like this, definitely if you measure the parameter, your performance parameter may change. ओके क्योंकि आपने पहले जो ट्रेनिंग डेटा यूज किया था वो 21 to 100 था, मॉडल ने उसको समझ के एक मॉडल बनाया, मशीन ने उसको समझ के एक मॉडल बनाया और उससे उसने परफॉर्मेंस मेजर 1 to 20 में. नाउ सेकंड केस में आप क्या कर रहे हो, 21 to 40 को आपने टेस्टिंग के लिए रखा और रिमेनिंग को आपके ट्रेनिंग के लिए. तो उससे मॉडल ने जो पैटर्न अंडरस्टैंड की, दैट कुड बी स्लाइटली डिफरेंट. ठीक है, तो व्हेन आई डू अ क्रॉस फोल्ड वेलिडेशन, व्हाट आई डू दैट I will change this iteration. If by 20% of a testing 1 to 20 21 to 40 and 41 to 60. Like that. I will change my training set. So with that, sorry, I change my testing set. So with that, the training set is also changed. Now with this training set, I will try to measure the performance. So यहाँ पे अगर आप देखोगे, तो I have a total n iteration. So let's say 5 iteration is there. In a 5 iteration, in every iteration, I am changing a testing set. 1 to 20 in a first iteration, 21 to 40 in a second iteration, 41 to 60 in a third iteration, 61 to 80 in a fourth iteration, and 81 to 100 in a fifth iteration. So this is my testing rate. And remaining is a training. So in a first case, 21 to 100, in a second case, 1 to 20 and 4 to 100, like that. And I am measuring the performance curve. Definitely the performance measurement parameter having a slight difference. But with the cross-fold validation, what I am trying to do, with all the iteration, whatever the accuracy that I am getting, I am taking average of it. So it may be a case that in a iteration 1, my accuracy is 85%. In iteration 2, it could be 87%. In iteration 3, it may be a 77%. But I am considering an average accuracy of each iteration and I am defining my overall accuracy. And that accuracy may be your 85% or maybe 80%. So here I am actually considering a learning model adaptability according to the data. It could be a case in a simple case. Let's say that कि मेरे पास डायबिटिक पेशेंट का डेटा, ठीक है, और डायबिटिक पेशेंट का डेटा मैंने ऐसे फीड किया कि पहले 30 इज अ डायबिटिक, फर्स्ट 30 इज अ डायबिटिक पेशेंट एंड रिमेनिंग 70 इज अ नॉन डायबिटिक. और जब मैंने इसको ऐसे बाइफरकेट किया 1 to 20, तो 21 to 100 उसमें डायबिटिक पेशेंट के डेटा 10 ही, जबकि नॉन डायबिटिक के 70. तो उस टाइम पे जो मॉडल ट्रेन होगा वो मॉडल क्या करेगा, वो डायबिटिक पेशेंट को तो बहुत अच्छी से नॉन डायबिटिक को तो बहुत अच्छी से डिफरेंशिएट करेगा, लेकिन डायबिटिक के डेटा बहुत लिमिटेड है, तो उसको वो फिक्स से समझ नहीं पाएगा. ठीक है. So that is what if I change the distribution 30-70, then there is a whole different game here. 31 to 70 उसमें आपका नॉन डायबिटिक का ही डेटा, तो आपका मॉडल नॉन डायबिटिक को तो 100% करेक्टली डायबिटिक, इवन आपके डायबिटिक पेशेंट को भी नॉन डायबिटिक बताएगा क्योंकि आपने जो डेटा सेट लिया है वो सिर्फ नॉन डायबिटिक. So this actually a change is being considered in a cross-fold validation where testing and training set is different is being considered, and through which the model which is being run, that variability is also being considered, and through which whatever the overall accuracy that I am judging is the average of it. तो आपका cross-fold validation करना बहुत important है, and particularly when it is a data imbalance. ठीक है. और यूजुअली हमारे हेल्थ केयर में दिस इज द प्रॉब्लम. आपको हेल्थी पेशेंट तो बहुत मिल जाएंगे, लेकिन पर्टिकुलर केस के पेशेंट मिलना मुश्किल है. तो डेटा इम्बैलेंस विल बी ऑलवेज देयर. ओके. So at that time the cross-fold validation is a very important parameter or very important method through which you can judge the performance of a. ठीक है. So this is all about the classification. Now I will stop at this particular moment because tomorrow also we have a lecture. I have a lecture from 6 to 8 where I supposed to take first this particular portion where I will talk about the regression, reinforcement learning, all this I will discuss it, and then we will talk about the basics of the Python. Now there are few announcements that possibly you just observe it. Then I will take up your question. Okay, because maybe people would leave. Okay, so before they leave, just pay attention to my announcement. Okay, tomorrow we would have a programming session. Okay, where I will explain you a basics of the Python. I will explain you how you can load the data to a drive. We will do the coding through a Google column. Okay, if you are interested to do a coding, then I request you to join through laptop. Okay, so that you can do a coding at your end. Maybe you can have one mobile phone where you can just observe the video, but you have a laptop also. So at that time, whatever is being written and whatever is being asked, that you can type yourself and you can observe the output, how it is running. Okay. So Jupyter also, if you want, then you can do it. But possibly, if you can go for a Google Colab, then it will be. If all are in the same platform, then it would be a good enough. Okay. Otherwise, you can do another software also. But Google Colab, possibly, if we all agree, then we can start with the Google Colab. Okay. And we will try to understand the basics of the Python tomorrow by writing a simple code. Okay. So that is my first announcement, that do come up with the laptop if you are interested to do the program. Okay. And the second announcement is that I am getting few query and few requests from a participant that sir, can we have a session little bit of early? So I'm not sure because we have announced it from 5 to 8. Okay. But if participants are agree, then we can have a 4 to 7 also, or maybe 4:30 to 7:30 also, or maybe 5 to 8 also. So for that, what I will do, first of all are requested to join our WhatsApp group because all the posts will be there over there, and as well as the Canvas link. So Canvas link, through a Canvas link, you will be able to get all the material. As well as important thing is quiz. So quiz has to be there, on a Canvas. ठीक है, तो वो आपको कैनवास लिंक जनरेट करना है. और दूसरा व्हाट्सएप ग्रुप में आई विल मेक अ वन पोल टुडे about the timing from tomorrow onwards. If you are interested 4 to 7, then give your vote to that 4:30 to 7:30, or if you want to put 5 to 8, that's okay. Okay. So I will consider your opinion only, that because some individual request is there, but I am not considering because there is a Navratri festival also. Okay. So that's why people have requested me. So I will put a poll in a WhatsApp group, and it will open maybe after half an hour or maybe just now. Okay. And tomorrow up to 11 o'clock, I will consider your opinion. Okay. So consider from current 8 or 8:30 to tomorrow 11. Maximum opinion, whatever is there, according to that, we will conduct the session from tomorrow. This is for only weekend days only. Weekdays only. For the weekend, we have already decided that we will go from 10 to 4 only. So it is not too early or not too late. We will not be too late. Okay. So currently I haven't set a material. Okay. Because today only the first lecture is completed. Okay. So we will share it on a daily basis. Okay. So I will share mine and I will ask Vinod sir also to share his PPT. So we will share. If not able to share it on a daily basis, then please wait for 1 or 2 days. But I will definitely confirm that all the materials with the permission of the expert will be shared on a Canvas platform. Okay. So that is all that I want to announce it. Okay. So now if you have any query regarding this, whatever is being covered today, then I will be more than happy to answer those. WhatsApp group की link मैंने आपको mail की है. Otherwise, if you are not received, because when I send you the confirmation mail, at that time there is a one link through which you can join the WhatsApp group. So all are requested to go back to your confirmation mail. I have sent you the participation confirmation mail. Okay. If it is not, then possibly you can send the individual request to me on my email ID. You can write down my email ID, amjoshi. Okay, amjoshi, email, amjoshi.ece@mnit.ac.in. But I request, before sending me a mail, do check your confirmation mail. I will send the confirmation mail again. Okay. So anyhow, you need to search the WhatsApp link. There is a one WhatsApp link is there through which you need to join. So I request to please join the WhatsApp link. Okay. So possibly I will allow all of you to join the WhatsApp link maybe in a 1 hour or 1.5 hours. Maybe at 9:30 I will start the poll, or maybe I can start with the 10. So let's keep it from tomorrow, today 10 to tomorrow 11. So that 13 hours when you need to provide we will open the polling, and when you need to provide your opinion about the classes time. Okay. Now, whatever is being covered, if you have any question, then this is the question. Okay. Recall parameter holds more value than precision. Actually, it means ideally for a healthcare domain, it is both are important. Precision is nothing but checking that whether I am able to identify the true positive or not. And recall is I am not missing any true positive. Okay. So in that sense, maybe recall has a higher slight edge because we do not want to miss any true positive case. Okay. But overall, in general, whenever you are solving any healthcare problem, so at that time, recall and precision both are equally important, and you need to find out that. Okay. I hope Pooja, I could able to give you the answer. Both are important. Recall, precision, accuracy, as well as, so that's why we are more interested in a confusion matrix. Because in a confusion matrix, when diagonal elements are higher, then I can consider that my parameter is good enough. Okay. If I have an imbalanced data set, okay, so if you have an imbalanced data set, then you need to apply the different technique. We will be discussing, okay. There is a smooth algorithm. So possibly in a Saturday class, that Anjali will show you that if there is an imbalanced data set, how you make it balanced. Okay, you need to make it balanced and then you need to apply to ML algorithm. So there are some techniques are there through which you can solve the imbalancing problem. And one or two techniques we will be discussing. Okay, during the program. But that all things will come once we have a basic understanding of the Python. And I consider that it could be a case that many participants doesn't have that basic understanding of the Python, or maybe a machine learning, whatever I have discussed it today. So that's why in first 3 days we are trying to see some of the basic things. Okay, and that we will actually dive inside. So अभी तो क्या है कि हम ऊपर तैर रहे हैं. We are only swimming, but we will go for a scuba diving. Okay, after 3 days only. Okay. Support vector machine. Support vector machine basically is useful, particularly, okay, where I want to solve the problem of the multi-classification. Okay, and where there is a more correlation in the data set. Okay, so definitely for the support vector machine, we will be discussing 1 or 2 case studies. Okay, at that time you will be able to realize it more better. But mostly for a multi-class and where the data point characteristic is marginally similar. So at that time we will use a support vector machine. So other than this metric, there are kappa value or ROC curve can throw some light about that. Yes, we will be discussing, okay, when we will talk about the ROC, we will talk about the AUC also. Okay, so all these things, when we talk about the case study, definitely we will be discussing that. But in this particular introduction section, I want to just cover the basic, because ultimately here in a classification, your confusion matrix is important. So that's what I have covered. Okay, we will be definitely discussing at the time of the case study ROC curve, AUC curve, so all are important. Okay. What should be the value of K? How to decide it? Okay, for the KNN classification, your class is already defined. That K is nothing but the class. Okay. So before friend, so it is something like that. If I want to point out, let's say for the cancer patient, that whether a particular patient is having a cancer or not cancer, then it is a binary classification. There is a 2 class one. So K is 2 in this case. But if I want to identify in a cancer stage 1, stage 2, stage 3, stage 4, and then there is a 5th stage, or there is a 5th case which I consider no cancer. And it is a 5 class problem. So here the K value is 5. Okay. So K is fixed always according to the application. So what actually you want as a prediction? So according to that you will judge that what is the K value. Okay. I have Rachna, I think, if I'm not wrong. Rachna, I have given you the answer. So many things, as I said, that you will be able to realize it when you go more deeper, अभी तो हम उसको ऊपर से ही देख रहे हैं, ठीक है? But when we dive into the application at that time, all these things we will be discussing. That when you need to think about the ROC, when you need to think about the AUC, okay? So that all we will be discussing, definitely. Yes, any further question? If there is no further question, then we will end up our day first. Thank you all for joining. And as I said you, that I will open a poll today around 9:30. Please give your honest opinion for that, and what you want from tomorrow regarding the time. Okay. Thank you all of you. See you tomorrow.